Okay, now I know the answer.
Yeah, now that we all know the answers. All right, here's all of our words for addition, all of our words for subtraction, multiplication, and division. Right below that, we have parentheses phrases and turnaround phrases. Just being able to familiarize yourself with this will help you translate all of these words into an expression or an equation. And we'll get there in just a second. So let's look for these words, and then it'll make a lot more sense, and it'll help you to translate those into those expressions. Let's take our first example. All right, the product of a number and 3. So what you're looking for are those words that we wrote up top. So product is one of them. And then I get to this word, a number. So whenever we don't know a number in algebra, we represent it with something. What do we represent a number with in algebra when we don't know something?
A variable.
A variable, that's it, yes. You can choose any variable you want, but for these examples, let's use the variable n. Let's use the variable n. Okay, perfect. So this is a variable. And for this, we're going to use the letter N. You could use any one you want, but we're going to use N for this one. So the product of a number N and 3, product tells me to multiply. So I know I have to show N times 3. Another way to write that would be what?
And parentheses 3 or it could be n times 3.
Yeah, even 3 times 3n there would be perfect. Nice job. Number 2. The difference between a number and 10. Difference is the first word that pops out to me. I know it means subtraction. A number, we're going to represent that with our variable n and 10. So the difference between a number and 10. We need to subtract, we know that. What are we subtracting?
Won't you do like 10 minus n or n minus 10?
It's going to be one of them. It's definitely going to be one of them.
So n minus 10?
Yes, good job. These get very confusing, especially with difference. So just be careful with that and try to read back to yourself. So the difference between a number and 10. Number 3. So number 3 is, let me tell you a quick personal story. When I was in high school, I was asked to find the quotient of 2 numbers. The quotient of, let's just say 12 and 6. I couldn't tell you what the answer was. I had a calculator in my hand, and it's not that I didn't know how to use the calculator, it's that I didn't know what the words meant. So this section of the notes for me is very, very important, because for that moment I felt very stupid. I was too embarrassed to say I don't know what the word quotient means. But I wasn't stupid, and none of you are stupid. None of you are stupid. I want you to know that. So that's why we are learning this, and we're learning to translate these words. Quotient, we now know, means division. And although I'm writing it like that, whenever we write it in high school, we're going to use a fraction mark. So like we're going to make a fraction. So the quotient of a number and -5. A number, we don't know what that is, so we'll represent it with n and -5. So my question to you is, what is being...
I was going to say, wouldn't n be on top and -5 be on the bottom?
Absolutely. Perfect. And again, you're going to want to go back and read it through and make sure it makes sense. So the quotient of a number and -5. Perfect. Number 4. 4 subtracted from a number. The 4 tells me that this is a number 4. Subtracted from something. We're taking it from something. What are we taking it from? A number. That's going to be our n. So we have n, and we're subtracting 4 from it, n minus 4. Hopefully this is starting to make some sense. Number 5. The sum of twice a number and 7. It's a lot of words, there's a lot of math vocab in here. First one I see is sum. Sum tells me to add. Twice a number. If I have twice a number, what would I be multiplying that number by?
2.
2, exactly. 2n, twice a number. So right here, I'm just gonna write twice. I know we may have written it up top. Remember, you're gonna multiply by 2. So, times 2. So the sum of twice a number and 7.
So 7 plus 2n, or would be 2n plus 7.
In this case, either would work. I'm going to put 2n plus 7 because the commutative property of addition tells me that 2n plus 7 is the same thing as 7 plus 2n. However, if it was subtraction, it would be different. So great job. Let's look at number 6. The product tells me to multiply. As you go through these statements, you're going to want to have that chart that you have above with all those words. Underline all those key words that you see. A number, we don't know what that is, so we're going to represent that with our variable n. Increase by 1. That's telling me to add 1. So let's reread that. The product of a number and 10 increased by 1. So it's just the first part. The product of a number and 10. Just like this one, the product of a number and 3. How do you think we should write the product of a number and 10?
1 and 11.
Close, close. So the product of a number and 3, we can represent with 3n. The product of a number and 10, we can represent
10n.
10n, perfect. Okay, so we have that part of it. But now, that's going to be increased by 1, which means I need to
Add 1.
add 1. Excellent. We've got 2 more in the back. Flip your papers. All right. So we have these 2 are also expressions below here. We're going to talk about equations, but that's going to be in a little bit. So number 7, 4 less than a number squared. All right, something different here. The first thing is this 4 is going to mean the number 4. Less than subtraction. A number, and then I'm going to put squared. Well, we know a number is n. How do we square a number? We put a little exponent of 2. So over to the left here, just put squared. Whenever you see the word squared, you know you're going to take that to the power of 2.
So
If you see cubed, it would be taken to the power of
3.
3. Good job. So we know we have a number squared. We know we have n squared. I want 4 less than that.
So minus 4.
Minus 4. Last one. Twice a number. We talked about this. Twice a number. What did we write for twice a number? What do we multiply by to get twice?
2.
2. Perfect. Divided by 5. Divided by 5, so we have to make our fraction bar. Since we're dividing by 5, that's going to be on the bottom. And our 2n is going to be on top.